Good morning, students. Myself, Vijay Shankar from ECE department at Chibol Engineering College. Today, we are going to discuss about the examples of convolution and correlation. In yesterday class, also we discussed about some of the examples related to the convolution and the graphical representation for the continuous time signals. Graphical representation of the continuous time signals. Today we are going to discuss about the few more convolution examples with the discrete time signals. The discrete time signal. So yesterday we completed this one. The procedure what we have to follow to find the convolution by using the graphical representation. First of all, you can take the x of t is the first function, where an independent variable t is replaced by the dummy variable tau. Why we are replace the t by the tau means in the formula itself the x of tau, x of t minus tau is there. And the second point is y of minus tau is a mirror image of y of tau. That is y of tau is flipped, nothing but folded function. And third point, y of t minus tau represents the function of y of minus tau shifted to the right by t seconds. Shifted to right by t seconds. So add the t here, the 0 minus infinite to the infinite. Okay, so go on and shifting towards the right side for the folded function, my dear students. For the folded function. For a particular value of t is equal to a, the integration of product x of tau, y of a minus tau represents the area under the product curve. The area under the product curve. After finding out the shifting values of y of t minus tau and the x of tau, sum of all the terms is equal to a particular value of t is equal to a, the integration of product of x of tau and y of a minus tau represents the area under the curve. And fifth point is the procedure is repeated for the different values of the t. For negative values of t, the function y of minus tau is shifted to the left by t seconds. And the value of convolution obtained at different values of t, that is a positive and the negative. Okay. You have to follow these points to find out the graphical representation of two signals to find out the convolution. Okay. And this example is already seen. Already we discussed in the yesterday's class. Now you can see the graphical representation for the discrete time signal. Determine the response of linear time invariant system whose input x of n and impulse response h of n are given by x of n is given 1, 2, 3 and 1, and h of n is given 1, 2, 1 and minus 1, and arrow mark is also represented minus 1. When arrow mark is represented means the value is at n is equal to 0, and here also n is equal to 0. Previously that is n is equal to minus 1, and n is equal to 0, n is equal to 1, and n is equal to 2. Following. Without arrow mark also, the starting value is n is equal to 0. This is n is equal to 0. And here the n is equal to 0. And this one is n is equal to minus 1. Okay. And this one 1, 2. So the input sequence starts at n is equal to 0 and impulse response starts at n is equal to minus 1. The output sequence starts at n is equal to 0 plus minus 1. Whatever the left indices, we're calling it as a left indices of x of n. Because of y of n is equal to having x of n with the convolution of h of n. What is the leftmost indices? The lowest value. The lowest value of x value is a 0. And the lowest value of n, h of n is a minus 1. So that is the sum of this value is the lowest value of y of n. So minus 1 is the lowest value for y of n. Is a 0 for x of n, and h of n is a minus 1. Y of n is the lowest value is minus 1. And what is the highest value? Is a 0, 1, 2, 3. For 3 is x of n, and h is 0, 1, 2 plus 2. So total sum is a 5. That 5 is the highest value of y of n. Y of n. So totally how many samples is there? -1, -1, 0, 1, 2, 3, 4, 5. These are the samples we have in the y of n. So 1, 2, 3, 4, 5, 6, 7 samples we have. For this here, the 4 samples are there, and here these are 4 samples. Totally the samples will get as from -1 to the 5. -1 to the 5. And where we have to keep the value is at -1 and the 0. The arrow mark is at the 0. Okay, the 0 value. Let us see, the x of n is given. X of n is a 0, it's a 1, 1 is a 2, and 2 is a 3, and 3 is a 1. And h of n is a -1 is a 1, 0 is a 2, and the 1 is a 1, and the 2 is -1. Here the 2 is there, here the -1. First of all, what is the first step it is here? Second value, the x of n, you can keep it is a same folded function of the x of h value, h of -m. The folding is occurs at the 2. Folding is occurs at the 2, 0, my dear students. At the 0, there is a value is a 2. So what? Positive values will get in the negative values, and negative values goes in the positive values. So 1 is at -1, and -1 is at the -2, and -1 now it will get at the 1. So h of -1. H of -1. When n is equal to -1, when n is equal to -1, y of -1 here, sum of n is equal to -infinite to infinite, x of m, h of -1 minus m, -1 and the minus m. So shifting towards the right side, whenever you can add the values of t there, here you can take it as a n, because it is a discrete time function. Okay. And goes on shifting the value and multiply with the x of n. What is the value of y of -1, -2, and so on. Okay. So I will explain here. Given 1, 2, 3, 1, 1, 2, 3, 1, and 1, 2, 1, -1. So the x of n given 1, 2, 3, 1, and h of n given 1, 2, 1, -1. Okay, you have to find out the x of n and the h of n. Following my students. So x of n graphical representation. Here the arrow mark is at 1, and the arrow mark is at the 2. Arrow mark means n is equal to 0. At n is equal to 0, the value of x of n is a 1. X of n. Okay. This varies with respect to the n. And 1 is a 2, and 2 is a 3, and again 3 is a 1. Okay, my dear students. The h of n graphical representation is at 0, the value is a 2, -1 is a 1, and 1 is 1, and at the 2, -1. Where is value? So h of n. Now at the first step, we have to see that h of -1 folded function. Folded function. h of minus n, h of minus n. Okay, my dear students. At the folded, we'll get at the 0. There is no any change at the 0. It is just 2 only. Minus 1, whatever the value in the 1, we'll get in the minus 1. And at minus 2, whatever the value is there in the 2, we'll get it here in the minus 2, minus 1. And now the minus 1, it is in the get in the positive real axis. At 1 is also the 1. So h of minus n. Okay. Means at n is equal to 0, this value. At n is equal to 0, y of 0 is equal to the sum of n is equal to minus infinite to infinite. Not the n, my dear students, it is k. The formula for the discrete time functions x of k, h of n minus k. At n is equal to 0, n is equal to 0 means here is a value you can keep first of all is a n. N minus 2. So n is equal to 0, the value is y of 0 is equal to sum of k equal to minus infinite to infinite, x of k, h of 0 minus k is equal to sum of k equal to minus infinite to infinite, x of k, h of minus k. So I'm taking here the n as a dummy variable with the k and n here also the dummy variable with k. So you can multiply these two and add the sum. So in this x of n, observe here the minus 1 is a 0, minus 2 is a 0. Now I can multiply the values so on at minus 2, the 0 into minus 1. So 0 into minus 1 plus and at minus 1 here the 0, x value is a 0, 0 into what is the value of h of minus n is a 1 plus, and at the 0 x of n value is a 1, and at the 0 the h of minus n is a 2. So 1 into 2 plus, and at 1 the x of n value is a 2 into what is the value at 1? The value is a 1 plus, and at the 3, see the 3 value. So 3 and not the 3, 2. At the 2 the value is a 3, and here the 2 is a 0. 2 is 0 and 3 is 0 here. So 0 plus, and at the 3 the value is a 1, and here the 0. 1 into 0. So simply wherever the n values, n is equal to minus 2 to the n is equal to 3, you can multiply and add the values. See the first two terms is a 0, third term is a 2, fourth term is a 2, and fifth and sixth is also 0. 1 into 2, 2 into 1 is a 4. 2 plus 2. 2 plus 2 is a 4. So y of 0 is equal to 4. Therefore, y of 0 is equal to 4. Okay, my dear students. One value we got. Because it is a discrete function, the previous examples, yesterday we already discussed about it is a continuous time function. Wherever it is a overlap, we are seeing. But here at particular instant of times, at minus 2, at minus 1, and 0, 1, 2, and 3. Okay, my dear students. And multiply where the minus 2 and minus 2 of x of n and h of minus n, and so on. Okay. Then find at n is equal to 1. At n is equal to 1. And n is equal to, or at n is equal to 1. What is the y of 1 is equal to sum of k equal to minus infinite to infinite, x of k, h of n minus k. You write this as also when y of 1 is equal to sum of k equal to minus infinite to infinite, x of k, h of 1 minus k. Now I am adding 1 to the minus k. Previously 0. Okay, my dear friends. 1 minus k. 1 minus k means the previous value what we have here, h of minus 1, we can add 1 and shift it towards the right side. Okay, one sample is shifted towards the right side. Okay, now I am drawing the h of 1 minus k. See here, minus 2, it now it gets at minus 1. Minus 1 value is at the 0, and the 0 value is at 1, and the 1 value is at the 2. So one sample is shifted towards the right side. So it is a minus 1, 1, 2, and 1. Minus 2, now it is a 0. Minus 1 is a minus 1. The 0 value is 1, and 1 value is a 2, and the 2 value is a 1. Okay, 3 is a 0. So one sample is only shifted 1, 1, 2, 1. 1, 1, 2, 1. So the minus 1, 1, 1, 2, and 1. One sample is ahead. Minus 1, 1, 2, and 1. Now it is multiplied with the x values. What is the x? X is the same. Nothing is the difference, is the x value. So y of n is equal to, at minus 2, there is also 0. 0 into 0 plus at minus 1, x is a 0, and h is now the minus 1 plus, and at the 0, what is the x value? Either 1. Okay, 1 into 1 into 1, x value is a 2, and here it is a 2. So 2 into 2, 2 into 2 plus at 2, the value is a 1, and here at 2, the value is a 3. So 1 into 3 plus, and at 3 here the 0, here it is a 1. So 1 into 0, 1 into 0. So now can add all the values of 0 plus 0 plus 1 plus 4 plus 3 plus 0. You get the 3 plus 4 plus 1 is a 7. So what is the y of 1? Is a 7, my dear students. Y of n we got as a 7. Similarly, at n is equal to 2, n is equal to 2 means now you can add the h of 2 minus k. So again it is a shifted one sample. Minus 2 is a 0. Now the minus 1 is also 0. At 0, the value you will get it the minus 1. And 1 is a 1. 2 is a 2. 3 is a 1. So minus 1, 1, 2, and 1. Shifted values. Okay. So y of 2 is equal to, now the value is the sum of k equal to minus infinite to infinite, x of k, h of 2 minus k. H of 2 minus k, shifting towards the right side only. Okay. Now at minus 2 the value is a 0 and minus 1 is also 0. Now add the 0 value. Here there is a x value is 1, 2, 3, 1. 1 into minus 1 plus 2 into 1 plus 3 into 2 plus 1, 2, 3, 1. Okay, my dear students. 1, 2, 3, 1. 1 into 1. Okay. So minus 1 plus 2 plus 6 plus 1. So add the 0. There is a 1 here, here minus 1. So 1 into minus 1. Add 1. There is a 2 and here it is a 1. So 2 into 1. Add 2. The x value is a 3 and h of 2 minus k is a 2. So you can multiply the 3 into 2. And n is equal to 3. X value is a 1 and h of 2 minus k is also 1. So minus 1 get cancelled. The value is 8. So therefore y of 2 is equal to 8. Y of 2 is equal to 8. Okay, my dear students. Again, this value, the next value is h of 2 minus k is now it is h of 3 minus k. Okay, at n is equal to 3. So y of 3 is equal to sum of k equal to minus infinite to infinite x of k h of 3 minus k. What is the h of 3 minus k? The value is h of 3 minus k. At 0 is also now the minus 2, minus 1, all the values is the zeros, my students. Now it starts at the 1. 1 is a minus 1. Okay. The values is 1, minus 1, 1, 2, 1. Minus 1, 1, 2, 1. Okay. 2, 3, and 4. What is the x of k, my dear students? X of k, you can write there is no any change in the x of k. For minus 2 is a 0, minus 1 is a 0, 0 is value 1, 2, 3, 1. Here the 0 is a 1, 1 is a 2, 2 is a 3, and 3 is a 1, 1, 2, 3, 1. Now multiply. Here the 0 is there. At 0 the value is 1. 1 into now the h value is a 0 there. And at 1 the x value is a 2 and the h value is a minus 1. Plus at 2 the x value is a 3 and the value is a 1. 3 into 1 plus and at 3 the value is 1 and the 2. 1 and the 2. Okay. Now it is a minus 2, 3 and the 2. The value is a 3. So y of 3 is equal to 3. Okay, my dear students. A similar way, at n is equal to 4. What is the value? Y of 4 is equal to sum of k equal to minus infinite to infinite x of k h of 4 minus k. Now again, one sample is shifted. The h of 4 minus k, the one sample is shifted towards the right side only. The 0. In now the 1 is also 0, my dear students. 0 is a 0, 1 is also 0. And the 2 is minus 1, 3 is 1, 4 is 2, and 5 is 1. Okay. Now multiply the values. At 0 here, 0, there is no any value here, the 0, that is a value 0. There is no any value at the 1, that is also 0. And 2, 3 values only we have. What is a 2? 3 into minus 1 because the value of x is at the 2, the 3, and here is a minus 1 plus the value at the 3, the 1 and 1. So 1 into 1. The remaining all the values is a 0 because if the 4 is a 0, 0 into 2 is a 0, and 5 is a 0, 0 into 1 is a 0, my dear students. Minus 3 into 1. Minus 3 plus 1. Therefore, y of 4 is equal to, what is the y of 4? Minus 2. Y of 4 is minus 2. And finally, at n is equal to 5. What is n is equal to 5? Y of 5 is equal to sum of k equal to minus infinite to infinite, x of k, h of 5 minus k. Now again, you can shift one sample towards the right side. Again, I will shift the one sample right side. 0 is a 0, 1 is a 0. Now here the 2 is also 0, my dear students. What is a 3? 3 is minus 1. 4 is 1. 5 is 2. And 6 is 1. The value is a h of 5 minus k. 5 minus k. Now multiply these two functions at particular instance. 0 is a 0, 1 is a 0, 2 is a 0 for h values. But the 3 here is 1 and here is a minus 1. So 1 into minus 1. The value is a minus 1. So y of 5 is equal to minus 1. Okay, my dear students. In the starting itself, I explained that. So y of 5 we find out. And what I said, the x of n having the values is starting with 0, the arrow mark. What are the values there? X values 1, 2, 3, 1. 1, 2, 3, and 1. These are the values we given for the x. H of n values. H of n values is given 1 to 1 minus 1. 1, 2, 1, and minus 1. So listen carefully, my dear students. After getting the y of n, convolution y of n, I will explain an interesting topic. How we got this y of n. Doing the convolution shifting, we shift adding one value and shifting towards the right side, adding one value, shifting towards the right side. Is a simple multiplication only. In the elementary school, we did that multiplication. That multiplication value only this one. That is very interesting, we'll get. Okay, these are the values is given. What is the lowest indices? I told the y of n. X of n is varies from the 0, 1 to 3. 0 to 3 is a range, intervals, and h value is 0 to 3, and h values is 1 to minus 1, 0, 1 to minus 1 to 2. Okay, what is the y of n? Y of n interval is 0 plus minus 1. So it starts minus 1 to 3 plus 2, 5. Okay. So no need to find the y at n is equal to 6, my dear students. Previously we find starting at n is equal to 0 onwards. N is equal to 0, 1, 2, 3, 4, and 5. But here see, it starts from the minus 1. Minus 1. Minus 1 means at n is equal to minus 1. What is the function? The minus 1 sum of k equal to minus infinite to infinite x of k. H value getting the minus 1 minus k. Minus 1 minus k means h of minus k. This is h of minus n. This value shifted towards the left side, my dear students. This value is shifted towards the left side. Got it, my dear students? Left side. Because we are adding the negative values. When we are adding the positive values, you can shift towards the right side. And we are adding the negative values, shift towards the left side. So what is the left side value? Here itself, I will do that one. The h of -1 and -k. Towards the right side, towards the left side. So 1 will get at the 0, 0 will get at the -1, and -1 will get the -2, and -2 will get at the -3. So start at the -3. That -3 is -1, and -2 is 1. -1 is a 2. And 0 is 1. And what is the 1 value? The 2, whatever we have, 1. So 1 sample is shifted towards the left side. Now this multiplied with the x of n. X of n at n is equal to -1. What is the value here? There is no any value in the -3 here in the x of n. That is a 0 into 0. There is no any value in the -2. That is also 0 into something here. And at -1, there is no any value at -1. But only the value at 0 here, and here also the 0. But 1 value, h value is a 0. At 2 value, h value is a 0. At 3 value, h value is a 0. So only there is a 2 values at n is equal to 0. 1 into 1. So y of -1 is equal to 1 into 1. That is y of -1 is equal to 1. Okay, my dear students. So now we can write the sequence. Y of -1 is equal to 1. So I'm removing here this one. No need to write. What is the equations? Y of n is equal to, it starts at the -1. What is the -1 value we got? At y of -1, 1 value, and y of 0, n is equal to 0, the value is of 4. 1 and 4. Okay. 1, 4. The 4 will get at the 0, my dear students. It means give the arrow mark it here. Okay. Arrow mark is at 4. And what is the value at n is equal to 1? N is equal to 1, we got the 7. N is equal to 2, the value is 8. 7, 8. And n is equal to 3, the value is a 3. N is equal to 4 minus 2. 3 minus 2 minus 1. 3 minus 2 minus 1. Now see, the lower limit is at -1 and upper limit is at the 5. -1, 0, 1, 2, 3, 4, and 5. So for the given values of x of n and h of n, we got the y of n is equal to these values. Now I told, after completing of all the convolution finding of y of n is equal to x of n and h of n, for verification. For verification, this is very important. For verification, and it is also interesting, my dear student. For verification, see what the values is given: 1, 2, 3. 1 is the x values, and multiply with the h values. 1, 2, 1, minus 1. Okay, simple multiplication. 1 into minus 1 into -1, minus 1. -1 into -3, not the -3, into 3 is -3. -1 into 2, -2. -1 into 1, -1. And now second value, 1 into 1, 1, 1 into 3, 3, 1 into 2, 2, 1 into 1 is a 1. And with all 2 value, 1 into 2, 2, 2 into 3, 6, 2 into 4, 2 into 2, 4, and the 2 into 1 is a 2. And the last value is also 1. So 1 into 1, 1, 1 into 3, 2, and 1. Now add all these values. Minus 1, 3 minus 3 and 1 is minus 3 and minus 1 is a minus 2. And here the minus 2 get cancelled is a 3, 3. And minus 1 get cancelled is a 8. And here the value is a 3, 4, 7, 8. Here it is a wrong we got. And is a 2 into 2 is a 4 and 1. These are the values we got. 1, 4, 7, 8, 3, minus 2, minus 1 is a 7. Actually, it is a 8, my dear students. Let us see. There is a wrong we got at the n is equal to 1. That we can see that n is equal to 1. At n is equal to 1. Here, 4, 3 plus 1 is there, my dear students. 4, 3, 1, and it's a 8. Addition is wrong. I did the addition is wrong. Already we wrote the 1 plus 4 is a 5. 5 plus 3 is a 8. Okay. And this value is also 8 minus 8. Okay, got it? Finally, what is the values for the y of n? The multiplication of the two functions only. Multiplication of the two functions. Okay. So in the online, if they given these type of numbers x of n and h of n, what is a convolution? Okay, there it's a limited time is there. For that, you can multiply that like this and write the values of 1, 4, 8, 8, and 3, minus 2, and minus 1. But here, one confusion is there. Where you have to keep the arrow mark. Where we have keep the arrow mark. In the verification method. We know the 1, 4, 8, 8, 3, minus 2, minus 1. Where it is a value is 0. At n is equal to 0. That arrow mark, you have to keep that at x of n. The arrow before the arrow of x of n is a 0. There is no any values at the before the values of x. And before the arrow mark of h values is a 1. 0 plus 1. Value is a 1. So you can keep the arrow mark of y of n after one sample. Okay, my dear students. If they give n, suppose x of n is equal to 1, 2, 3, and 1. The arrow mark is now here itself. The h of n is the same. How many number of samples are there before the arrow mark of x of n? The 2. So 2 plus 1, what is the value? Is a 3. So after the 3, 1, 2, 3, after the 3, you can keep the arrow mark. Understood, my dear students? So like that, you can keep the arrow marks in the y of n. Whenever if they given these values in the online, it takes there it is a limited time to find out the convolution without doing all these things. Okay, what we did, it start from the n is equal to 0, n is equal to minus 1, 2, 3, 4, and 5 up to so on. It takes a more time. The external examination point of view, there is a 7 marks and the 8 marks question. It is sufficient. But there, the 7 marks is given. Don't write this one. Verification method. They will give the 0. It is only for the verification method only. Another verification is also there. That verification, my dear students, is the first one. 1, 4, 8, 8. This is the 7, not the 7, my dear students. You can change this as 8. Now we got the y of n and the y of n is both the same. What is another verification? The sum of y is equal to sum of x and sum of h. What is the sum of y? You can add all the samples here. 1 plus 4, 5, 5 plus 8, 13, 13 plus 8, 21, 21 plus 3, 24, 24 and the minus 2, 22, and the 22 minus 1, 21. The y of n value is a 21 is equal to, what is the sum of x? 1 plus 2, 3, 3 plus 3 is 6, 6 plus 1 is a 7. And 1 plus 2 is a 3, 3 plus 1, 4, 4 minus 1 is a 3. So 7 threes, what is the 7 threes? The sum of x and 2. It is a multiplication. 7 3 is 21. 21 is equal to 21. Okay. Now we got the whatever the values we got. If suppose it is a 7, we got, okay, without doing this verification, the 7, we wrote the wrong there. 7 means it becomes of 20 on. But here in the left hand side, it is a 21. It is not satisfied. These also we can verify whenever you can complete your convolution by using the graphical representation of the discrete time signals. For the discrete time signals only, my dear students. Got it? So now you will get the interest. There is something interest. Is a multiplication values only. We got the y of n. The y of n is equal to simple answers. That is a simple multiplication. 1 multiplication, 2nd multiplication, 3 multiplication. Okay, got it, my dear students. So very interesting. So see, here also they will get the same answer. After doing all this, we already did this one. Finally, 14883 minus 2 and minus 1. Okay, my dear students. You can do the more examples. You can take anything. Or otherwise, you see that arrow mark is shifted towards the right side, arrow mark is shifted towards the left side, and verify the values. You will get the same values, but the arrow mark you have to keep there where it is in the y of n. Where it is in the y of n values. Okay. Now, another example here to find the convolution in the discrete. So 105 and 1, my dear students. 105, the discrete value. And remaining all it is a continuous time only. So find the convolution of x of t given that is a mu of t plus 1 and h of t is a mu of t minus 2. T minus 2. So using these values, so mu of t plus 1 and the mu of t minus 2, given it is, I will explain here. Another example in the continuous time signals. The continuous time signal they given x of t is equal to mu of t plus 1 and h of t is given mu of t minus 2. Okay, it's the same thing. Once again, you can see that is the value is the same or not. T minus 2 and t plus 1. Okay. T plus 1 and the t minus 2. Now, first of all, you can draw the graphical representation of mu of t plus 1. T plus 1, before that, we know the mu of t. Mu of t is a step function. It varies from the 0 to infinite with the variable of t. Magnitude is 1. Mu of t plus 1. T plus 1 means plus value is advanced function. Okay, it starts from the minus 1. Advanced mu of t plus 1. Actually, it starts at the 0 because it is advanced function. It starts at the minus 1. Okay. The value is varies with the t. And h of is x of t, my students. This is x of t. X of t is equal to. And h of t, what is the h of t is equal to mu of t minus 2. So this is a step signal is delayed with the 2 samples. Delayed means towards the right side. The 2 samples starts from the 2. Even here the magnitude is the same. What is the magnitude is a 1 only. And here also the magnitude is a 1 only. What do you have to do for the given after the graphical representation taken by for the x of t and h of t. The first step is a folded function. Folded function. What is a folded function? H of minus t. H of minus t means it is a folded function. It starts at the, you're folding at the 0 only because it is a h of minus t. It's not the h of minus t. Okay, it's a folded at the 0, the 1 value and the minus 2 value will get it here. This one. Total positive value will get at the negative value, and total negative values will get at the positive values. T. Now multiply these two. There is no any overlap in the multiplications here. It starts at the minus 2 and it starts at the minus 1. There is no any overlapping. Okay. So at n is equal to, and nothing but the t is equal to, at t is equal to 0, at t is equal to 0, so what is the y of t? Y of t is also 0 because there is no any overlapping. To draw this one, it starts at the minus 1 and you can multiply this, it starts at the minus 2 and here it is a minus 1. Now at t is equal to 1, we can add 1 at t is equal to 1. What is the h of my 1 minus t? 1 minus t. When we can add 1 means shift it towards the right side. So you'll get at the minus 1. So minus 2. So now we can see the overlapping here. At minus 1 there is a minus 1 and the minus 1 is also 1. But here also the y of t is equal to 0 because the integral y of t is equal to integral, because at the minus 1 to 1 the magnitude is 1. dt is equal to t with upper limit is a 1, lower limit is a minus 1. Here a minus 1 only. Upper limit is minus 1 and lower limit is also minus 1. So minus 1 minus of minus 1 is a plus, that's a 0. So at t is equal to 1 also, the value is a 0. So that is y of 1 is equal to 0. Now at t is equal to 2, that is again shifting towards the right side at the 0. Okay, my dear student. Shifting towards the right side means the value is at the 0, minus 1, minus 2 and the 0. So where it is overlapping occurs here? Here the minus 1 to the 0 and here also minus 1 to the 0. So what is the area here? Y of 2 is equal to, what is the varies from? Minus 1 to the 0. Minus 1 to the 0. This is the overlapping occurs here. Okay. The overlapping is at minus 1 and the 0 because here also the value. Minus 1 and the 0, 1 into t, dt is equal to t with upper limit is a 0, lower limit is a minus 1. So upper limit minus of minus 1 is a plus, the value is a 1. So y of 2 is equal to 1. Y of 2 is equal to 1. Again, you can shift towards the right side. And t is equal to 2. T is equal to 3. T is equal to 3. What is the y of 3 now? Y of 3 is equal to, means it is shifting towards the 1. So what is the value? See, minus 1 to the 3. Minus 1 to the, not the 3, 3, minus 1 to the 1. So what is the limitations here? Minus 1 to 1. 1 into dt. Again, we will get the t with the lower limit is a 1, upper limit is a minus 1 and lower limit is a minus 1. So 1 minus of minus 1 will get the 2. So y of 3 is equal to 2. And again, t is equal to 4. Shifted towards the right side. Means we'll get at the 2. So minus 1 into 2. Minus 1. Minus 1 to 0. Minus 1 to minus 1. See, the limitations is also changes here. It starts at the minus 1 only because x of t is minus 1. So minus 1 to minus 1, minus 1 to 0, minus 1 to 1. Then next value is minus 1 to 2. That t is equal to 4. At t is equal to 4, the limitation is minus 1 to 3. The one value is reduces here. So 2, not that one value. Here all the minus 1 to 1. Now the minus 1 to the 2. 1 into dt. So upper limit is a 2, lower limit is a minus 1 into minus 1 is a plus 3 value. So y of 4 is equal to 3. And t is equal to 5. Here it is a minus 1 into 3, 1 into dt. That value is a 3 plus 1 is a 4. So y of 5 is equal to 4. It is increases so on. Still it is a moving towards the right side. Is a so on the value is increases only. Okay. Up to the value of the infinite. T is equal to infinite. T is equal to infinite. What is the t is equal to infinite? Minus 1 to. It reduces of two values. All infinite minus 2. Infinite minus 2. So 1 into dt. That is equal to infinite minus 2. Minus of minus 1 is a plus. So that is equal to infinite minus 1. What is the y of infinite? Infinite is equal to minus. Infinite minus 1. So one value is reduces. At t is equal to 5, the value is a 4. At t is equal to 4, the value is a 3. So what is the y of t value in the graphical representation now? The continuous time only. See, at t is equal to 0, the value is a 0. 0 and t is equal to 1 also 0. 1 also the 0. Now, at t is equal to 2 onwards, it increases 1, 2, 3 and so on. Increases. At t is equal to 2, and slowly it is increases. At t is equal to 2. 1 value here. And at t is equal to 3, the value is at 2. At t is equal to 4, the value is 5. Is the value is t is equal to 1, and at 3 is equal to 3 is a 2. At t is equal to 4, the value is 3. You get the staircase, my dear students. And 5, 4, so and so on like this. It's a continuous time function. The 5, 6 and so on. And last value, the infinite value, it is an infinite minus 1. The staircase. So on the value 4. At 5 we'll get the 4. At 6 we'll get the 5. And the infinite value, it is an infinite minus 1. Got it, my dear students? Let us see in the example here. See, slowly it is increases. So 0 and 1 and the 2 and the 3 and the 4 and so on. All the values. Okay. You then actually have to draw that it in the linear only. But here we don't know. So see that it is not the staircase, my dear students. Sorry. The values is increases. At 2 the value and t is equal to 0. And the 3 is 1, 3, 4 it is value, 4 is value, slope. Why it is not the staircase means we don't know the value in between of 1 and the 2. It is also increases, but it is not the constant. In between of the t and 4 and 5, you can take the 4.5. 4.5 means it value is reduces 1, 3.5. 3.5 again it is increases only. It is not the constant, my dear students. What I did in the last, it is not the staircase. Sorry, it is a linearly increases. Okay, linearly increases. So on. Understood? So graphical representation. See, the y condition is y of t is equal to 0 for t is less than or equal to 0, and y of t is a t minus 1. So one value is reduces when the t is equal to 1, we'll get the 0, and t is equal to 2, we'll get the 1. So t minus 1. So this is a condition we got after the finding out the convolution between of x of t, mu of t plus 1 and the mu of t minus 2. What is the y of t? 0 for t less than or equal to 0, and the y of t greater than 0 is a t minus 1. Every time the t is increases, the y of t is also increases correspondingly. Got it, my dear students? Then next example. The x of t and h of t. X of t is given from 0 to 2 is a 1. Magnitude is a 1. And the 0 to 3, the h of t is a magnitude is a 1. The first of all, you can see that the h of t becomes of h of tau and x of t is x of tau. The folded function. Total negative positive values will get in the negative values. Okay. At t is equal to 0. Means at t is equal to 0 here. Now, there is no any overlapping here. Starts at the 0 and hit the 0. That value is a 0 only. And shifting towards the right side, the range is 0 to 1 value shifted towards the right side. 0 to 1. 0 to 1. The limitations at 1, at t is equal to 1, 0 to 1. At t is equal to 2, 0 to 2. At t is equal to 3, 0 to 2. At t is equal to 4, 1 into 2, and so on. Why it is a 1? There is a overlapping occurs here itself. Following my students. See here, there is no any change there until after the 2 function. Until after the 2 function, see the overlapping is where one step ahead, it is from minus 2 to the 1. Minus 2 to the 1. And one step ahead, minus 1 to the 2. And still a one step ahead, 0 to 3. Still one step ahead means 1 to 4. Still one step ahead, 2 to 5. Still you can go for the 3 to 5, there is no any overlapping. Following 0 to 1 and the 0 to 2. Next is a 0 to 3, 0 to 2, and then one is a 1 into 2, and 5, there is no any overlapping. So after that, we'll get the values. Draw a graphical representation. It is not the staircase, my dear students. Once again, I'm saying it is a slope, then it is a constant, there is a slope here. Following. See how I'll explain the values. See here. So I will draw here the h of minus 1. At the first case, there is no any overlapping. At t is equal to 0, the y of t is also the 0. At t is equal to 1, means this value, t is equal to 1, t is equal to 1. It is a shifting of one sample, my dear students. I will draw here. Shifting of one sample means it starts from the minus 2 and will get up to the minus 2, minus 1, 0, and 1. Up to this value. See here 0 to 2 and here the 0 to minus 2 to the 1. Where it is overlapping 0 to 1 only. 0 to 1. See here the limitation is a 0 to 1. At this the value is a 1. So y of 1 is equal to 1. Again, if the t is equal to 2, t is equal to 2 means this is a 1 value shifted towards the right side. This value is of h of 1 minus tau. Then I am writing the h of 2 minus tau. So one sample means it starts from the -1, 0, -1, 0, then after 1 and the 2. So 0, 1 and the 2. Here the arrow mark, it is here itself, my students. The arrow mark is here. There is no need of the value -1. And here also the arrow mark shows add the 0. So overlapping is here. Now what is the overlapping? 0 to 2 there. Here also 0 to 2. So at t is equal to 0 to 2, the value is a 2. So at t is equal to 2, the value of y of 2 is a 2. Okay. Then again you can shift this at the t is equal to 3 towards the right side only. Towards the right side. Okay. Don't write this before itself. One sample ahead. One sample means it starts at the 0, 1, 2, and the 3 is ends at the 3. So here you will get the arrow. So now comparing with the x value is a 0 to 2 only. 0 to 2. And here also the 0 to 2. But t is equal to also 0 to 2, the value is a 2 only. Y of 3 is also the 2. Because still there is an overlapping occurs here the 0 to 2 only. Here also the 0 to 2. Got it, my dear students? Then see for y is equal to 4, t is equal to 4. T is equal to 4 means this is shifted towards the right side. Okay. Don't write the before itself for the arrow mark here. Shifted towards the right side means it starts from the 1. 1, 2, 3, and the 4. One sample ahead. 0 is now here itself. 1, 2, 3, and the 4. Now what is the overlapping for the x value? X value is only from the 0 to 2 only. Now it is a 1 and 2. 1 and 2. T is equal to 4. The y value is 1 and 2. Integral 1 and the 2, 1 into dt. So 2 minus 1, the value is 1. So y of 4 is equal to 1. Y of 4 is equal to 1. Still it is a t is equal to 5. You can shift it towards the right side. It starts at the 2. 2, 3, 4, and 5. So n value is a 5. 2, 3, 4, and the 5. Because n value is a 4, 3, 2, and 1, so on like this. 2. What is the range of here? The x value 0 to 2 only. So the limitation of y is 2 to 2. 1 into dt. 2 to 2 means 2 minus 2 is a 0. So y of 5 is equal to 0. So what are the values here? T is equal to 0. The y value is a 0. See here. T is equal to 0. The y value is 0. T is equal to 1. Y value is a 1. 1 here. And t is equal to 2. What is the value of y of 2? The value is a 2. This is a 1 and this value is a 2. And t is equal to 3 also. The value is a 2 only. It is a constant. Now what is a 4? 4 is a 1. Decreases. And 5 is a 0. Now the graphical representation will get as a 0, 1, 2, 2. Here the value is a 1, 2 value, 2 value, and the 1 and the 0. What it matters, students? Like that, you can find out the convolution for continuous and the discrete. Whenever the first step is fix the value of x value and the h value is folded function. Then after shift towards the right side by adding the values of t's positive values. If you can add the negative values of t, you can shift towards the left side and see what is the final value and what is the initial value, and draw the graphical representation of a continuous and the discrete also. Here the discrete is a discrete function. Okay, we do it in the tomorrow class. I will explain this in the discrete values. It's a very interesting discrete values and the convolution. So only the two examples are there in the convolution, and remaining you can see the for examples of correlation 1 or 2. The one examples problems of autocorrelation, the cross correlation. The two examples are there. And the last topic we have, that is extraction of signal from the noise by filtering. Okay. Tomorrow and the day after tomorrow, we can close this fourth unit. Any questions? Okay. Thank you.